Hello, hope you guys are doing well. So today we are going to solve a LeetCode problem of the day 3093 and its name is longest common suffix queries. Let's first read this. You are given two arrays of string, words container and words query. So we are given with two array. First one is words container and another one is words query. Now for each words query I, you need to find a string words container. Now for each of the query we have to find a result like that has the longest common suffix. Now suffix, whenever we come across with the word suffix, just think of the data structure, try data structure, and if it is possible then go ahead with that data structure. Now for most of you, try data structure will be a new data structure, but I'll tell you from the like scratch how try. It's like way simple. It's just kind of like a tree, self-referential data structure. I'll tell you first. Let's read this. With words query, if there are two or more string in word container that shares the longest common suffix, find the string that is the smallest in length. Find the string that is smallest in the length. If there are two or more such string that have the same smaller length, find the one that occurred earlier in the words container. Return an array of integer answer where answer I, like I have to take each word from my word query and find the longest common suffix like cd. Do cd match with this? Yes. With this? Yes. With this? Yes. Now out of all these string, I have to come up with the string which that is smallest in length. Which one is that? It's on index 1, so that's why I'm writing 1. Same goes for like, and then finally we have to return that array. Answerize the index of the string in words container that has the longest common suffix in words query I. So let's see this. So LeetCode problem is 3093 and it's already solved hard. That's all. So now let's see. I have a word query, right? It is 3093. I'm given with this query, word query. So I have to come up with the answer that is of length 3 because words query length is 3, right? CD. What is the longest common suffix? Yeah, CD itself occurs in all of the string. So out of all these string, which is the string that has the minimum length? It's BCD. So what is its index? Its index is 1, so I'll write 1. What about BCD? Again, it matches with this, it matches with this, and it matches with the 0th index as well as, but I have to come up with the smallest string, so it will again be index 1. Same goes for XYZ. Does XYZ match with this? No. Does XYZ matches with this? No. Does XYZ matches with this? No. Now what is the common like longest common suffix? It's an empty string, right? Since it is an empty string, so empty string matches with this as well as this as well as this as well as this as well as this as well as, so I'll again return what? 1. So I think the first test case is clear. Let's see, let's look at our second test case. So this is my second test case. So I'll come up with an answer array that is of length 3. Is that clear? GH. Yeah, right. So what is its length? 1 2 3 4 5 6 7 8. What is its length? 1 2 3 4 5 6 7. What is its length? 1 2 3 4 5 6. 1 2 3 4 5 6. 1 2 3 4 5 6 7. Yeah. So GH matches with each of them. Which is this string that, like, tell me the string that has minimum length? It's this one. So I'll index, its index is what? 2. So I'll write 2. What about acbfgh? AC, like GH, yeah, it matches. GH matches and GH matches, FGH matches. So it's what? FGH matches is the longest common suffix because we cannot take GH. So I'll write here what? 0. Again, ACBFEGH. GH matches with each of them. then E. Nobody matches. So GH is the longest common suffix because here matches EGH, no EGH, no EGH, no EGH. So again I'll consider this one. So my index will be what? 202. So 202. So initially I mentioned whenever the prefix matching or suffix matching comes into the picture, we have to explore which data structure matching. It's the trie data structure. So what is trie data structure? It's similar kind of self-referential data structure. Self-referential data structure. So now like we'll create a trie data structure. Now what is trie? Trie is kind of tree data structure. So I'll have a node where I'll having how many indexes, like from 0 to 25, like each of the node representing whether that node exists or not, right? 1, 2 and so on till 25. So 0 represents what? A, B, C and so on till Z, right? Now the thing is, if like initially each of them will be null, it's not pointing to anything, 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 it's not pointing to anything. Initially it's a self-referential data structure, kind of tree. In tree we have one node, right? One node points to left, right. If it is a binary tree, then otherwise we have many other nodes as well in case of tree. But the thing here is we'll have one node, but each node will have like multiple indexes. Each of them will refer to the same data structure. So if A is null, that means A is not present. If B is null, like if it is pointing to the same trie, that means A is present. Let's fill A, B, C, or let's take our ABCD. First we'll fill ABCD. So A will point to this thing. Now A, B, C, D, so on. Now the B will be what index? B will be at what index? It will be on index 1. So I'll again point it to trie. I'll again point it to the node. This is my node, right? And if it is pointing to node, that means that index that letter is present. B, C again. Now each of them are null. Now C will be at what index? It will be at index 3. Now again it will point to what? Trie data structure. This is my node. Now D, if it is D, A, B, C, D, it will again point to another node. So this is how my trie will look like. If it is null, that means the index doesn't exist. So this is how I'll fill. Let's create a trie data structure for this one. So this is I want to represent it on trie data structure. Now initially everything will be like this, right? Now it will point to what? A, trie A, and remaining one will be empty. Now this one will point to what? Now this is pointing to A. Sorry. Let's this is what? This is my initial node. Initially it will be empty from A to Z. Now since A is present, I'll do what? I'll create a node from A, right? Then once it is done, I'll create a node from where? From B. From B I'll create a node. Then from C I'll create a node. Then what? From D again I'll create a node. And finally it will be all empty. So this node represents what? Like this node represent empty string. This node represent A. This node represents what? AB. It represents what? ABC. And this node represents what? A, B, C, D. That's it. Now BCD. Now from B, I'll do what? Create a node. Now again from C, create a node. Now again from D, create a node. So it's what? Empty, it's B, it's BC, and it's BCD. Same goes for XBCD. So let's take X here. X, I'll create a node from here. It will be what? B, and again it will be what? C, and again it will be what? D. Right? It represents empty node, it represents X, XB, and it represents XB, XBC, and it represents what? XBCD. So this is how my trie will look like. Now each of node will have like self-referential data structure along with two values. What is minimum length, and the another one will be what? For what index we are having the minimum length. Let's say if till here it is representing some string, right? B is representing ABC. So what is the minimum length? What is the minimum length? While like filling a trie structure, I'll maintain a variable min length. I'll maintain a variable min length. This tells me what is the minimum length. What is the minimum length that's imparting ABC is imparting what? ABC is imparting this one, right? But we are given with suffix. That thing will consider later, but now time being, now I'll take the prefix, right? So ABC, if it is B, what is the string with minimum length? It's the one only, na? And its index will be what? Its index will be 1. Let's take now D, DC, and B, A, right? Because we want to compare the suffix, so I'll reverse them. I'll make it D, C, B, A, D, C, B, D, C, B, X. Similarly, I'll reverse them, CD, and then DCB, DCB, and GYX. Now I'll find the maximum prefix. We can use the trie data structure. Now fill DC. When I'll fill DC, it will be what? Let's erase this one. If it is DC, because I want to fill D, so it will what? D. So it represents empty string, it will be my D. Now when I'll fill this one D, it's with it will fill with D, right? So whenever I'll iterate over this string, its length is what? 1, 2, 3, 4. So initially I'll consider its length as max value. So since its value is max, so I'll do what? Whenever I encounter length, a string of length 4, I'll update its length. So D is impacting which one? D is impacting the 0th one. So I'll make its index as 0 and length how much? 4. Now whenever I'll encounter this one, DCB, again I got D. Now D, the length of this string is what? 3. So it's lesser than this, so I'll update 3, and at what index? 1. So along with the node, I'll keep the minimum value, like minimum length that's making this string, and along with its index. Like we need to keep the track of 3 things: whether that children is null or not, along with that the minimum length that's impacting this string so far. So D, again I encounter this D, it's already 4, so I won't update this. Again DC, similarly I'll do from from this, it will be from D, I'll create this one. Again C will be pointing to something. So since this node is D, so its minimum length will be what? 3 and index will be 1. So it represents what? DC. DC minimum length is what? Again it will be 3 at index 1. DC and then DCB. It represents what? DCB. DCB and its length is what? 3. And at what index? 1. DCB. Again I'll do A. So DCBA. So DCBA. So DCBA is what? DCBA. It exists only at index 0. So its length is what? 4, 0. So I think this thing is clear. Now when I'll compare D. So D will be here. So it's at index 1. Again I'll go with C. Its index is 1. So I'll write 1. Same goes for BCD. B. Now I have to create with B also. B. It represents what? B. Then it represents what? BC. It represents what? BCD. So for B, what is the minimum length? Its minimum length is 1. What about BC? Its minimum length is 1. What about BCD? Its minimum length is 1. So length is 3. Length is 3. Length is 3. Length is 3. And at what index? Index 1. So when I'll go with BCD, I'll come here. I'll match B. Do B exist? Yes, I'll go here. Do C exist? I'll go here. Do D exist? Yes, I'll go here. So what is the minimum length? It's 3. What is at what index? 1. So I'll return 1. Again XYZ. So it will point to X. It will point to XY. It will point to XYZ. So it's X, it's XY, it's XYZ. So Z. Is there anything? Z? No. So its length will be what? I have to update its length as well as whenever I encounter a word whose length is lesser than this. So it will be what? Its length will be 1 and index 3. Because like if there is no mismatch, if there is no matching, no suffix common, then I have to return the index of this string that is the minimum, right? So now let's say I know this question is tough. You have to solve some few questions before like solving this question. It's a hard problem. So let's see. So I have to first create the structure of node. Then I have to create a trie data structure. Then I have to use this data structure to solve my problem. So let's do step 1. So how my class node will look like. So let's create a class. Now since it's a self-referential data structure, it will have how many, like it will be an array. Array of what? Array of node. Like each node will have how many nodes? How many nodes? How many children each node going to have? 26. So 26. Now each node will have its minimum length because each node represents a string and that string will have some minimum length. And at what index is like at what index is helping us to get that minimum length string? That will be stored in index. Now create a constructor node. Now this dot children equal to what? New. This row children equal to new and node how many? 26. Now this dot min length will be what? Equal to int max. Integer dot max value in Java we have. Let's write it in max. What about index? Let's keep it -1 or whatever you want. So that's how I'll initialize my constructor. And now node is created. Now this is very important, trie. So let's create a class trie. So whenever we are creating trie, each trie will have their unique root. So node root, right? Create a constructor for this. This dot root equal to what? Root is of type node, so instantiate it, new node. Once it is instantiated, now I'll do what? I'll have to create two functions. First one is to insert and second one is to query. So let's create the function for insert. Let's create the function for insert. So for insert, it will return what? Void. Let's name our function insert. It will need two parameters. First one is string s, the string that I want to insert, and second will be for what, like what is the index of that string. Now create a current node. Current node will be initial, will start while inserting, will start from the root node. So current node will be equal to pointing to what? Root node. This dot root. Is that clear? Now if current node, now find out the length of the string as dot length. Now if the length of the current node dot length, because we are on the root node represents what? Empty string. If current node dot length is what? Min length. It's min length, right? Min length is greater than length, then do what? Just update your current node min dot min length to what? Min length to, let's increase it. No. Let's increase. How can we increase? So min length will be what? New length. And you have to update its index as well. Current node dot index will be equal to what? The index that we are given in the argument idx. Now once this is done, I have to do what? I have to insert my whole string for char ch as dot to char array. Like this is the strategy to iterate over the whole string. Now we are on index ch. Now find out the index. How to find out the index? Just reduce the minus a from it. Now I have got the index. If that index is already null, if it's null, then we have to like point new node. New node represents what? That node, that character exists in my trie data structure. So if current node dot children of c equal null, I'll do what? Do nothing, just current node dot children of c equal to what? New what? Trie or node? Children is of type node, so new node. Just it will point to a new node. Once it is done, I'll come to its children, because I want to insert the next character to its children. So current node will be pointing to what? Current node equal to current node dot children of c. I know it's a bit tough, but when I'll start my series, like you guys will get to know it like in a way simpler manner. Solving directly the hard problem is like you have to have very much context about this, then only you can solve this problem. But fine, let's see. Current node dot children equal to c. Once it is done, compare if current node dot min length, like the very same condition I have to write here. Just check if current node minimum length is greater than the current length, then update that length along with its index, because I want to keep track the string that has been made so far. I want to get the minimum minimum length string that's making this string like prefix. Once it is done, I'll just close it, and again I'll close my insert function. Now let's create my insert function is already created. Now let's create my query function. So in query, I'll return an index int query. Here I'll be given with a string as. Now if iterate over your whole array, whole string, sorry, for char ch equal to what, as dot to char array. Now the thing is, if initially create your node, current node will be the what, root node. If current node dot ch minus a equal to what, is not equal to null, that means that string is present to explore further. So make current node what, current node equal to current node of ch minus a, right? Once this is done, I'll do what, that's all. Otherwise just break, because we end up with a string that we cannot explore further. Finally return what, return current node dot index. That's it. This is how my try data structure will, like try class will look like. Now the thing is processing. Now we have each of the string in container. Now I iterate over the whole container and reverse each of this string and then insert, because instead of prefix we are finding what, suffix. So that's why we are reversing our string. So reverse them. After reversing, insert them. Once your try data structure is built, you'll do what, you'll query each of these string in queries. Now query each of them and find the index that gives us the best index. Best index means what, the string with the minimum length, the string with the minimum length. So let's try implementing its solution. So first I'll create what, I'll create the node data node, how my node will look like. So it will be class node. Now each node will be pointing to the 26 node. So node, these are my children. Now each node will have its minimum length, each node will have its index. Now while I'll create a constructor, this dot children equal to what, new node 26. This dot min length, initialize it what, integer dot max value. This dot index will be what, this dot index will be, let's create it minus. Now node data or whatever you want, because ultimately we'll update it. Now how your try class will look like, class try. Now each try, like whenever you are, each try will have its root node. So create node root. Now create a constructor for this. Try this root will be equal to what, new node. Now it will have two functions. One is to insertion. So let's write the function for insertion. Now void insertion. It will take two index, string as int index. Now once it is done, I'll do what, just create a node, just create a node of what, current node. That will be, current node will be pointing to what, this dot root. Current node will be pointing to this dot root. Now the thing is what, the thing is current node this dot root. this dot root. Now the thing is what we are supposed to do. Actually I'm having a call, that's why I'm distracted, but let's get back to the problem. In node current node equal to this dot root, I'll do what? I'll just find the length of my string. Length will be what? S dot length. Now if current node dot minimum length, if it's already, if it is less than or if it is greater than the current length, then we are supposed to update current node dot min length will be updated to what? Length will be updated to what? Length, and current node dot index will be updated to what? Its index itself. Now start filling from the first character, very first character. S dot to char array. Now now do what? If, like, first find the index for that character, it will be ch minus a. Now if current node what? C, current node dot children is null for C, equal null, then initialize it with new node, because I want to make sure that this node remains node null. Node null represents this character exists, equal to new node. Once it is done, do what? Just do current node will be pointing to its children. Now current node dot children of C. Once it is done, I'll do what? I'll do the very same thing that I have done here, because I want to check. I want to update the index. If, like, the index, if the current string has been made with the string that is lesser in length, then update its length and index as well. Once it is done, I'll come out, and that's how my insertion will be done. Now the thing is, control gen. I'll be querying. Querying is way simpler. It's far more. So it will be returning the index that results in the longest common prefix along with its index. So query string s. Now node cur node, initially it will be pointing to root, or what? It's root. This dot root. Now for char ch s dot to char array. Now it's pointing to s dot to char array. Now if node dot children of ch minus a is not equal to null, then go to its children. I'll be doing what? Node will be pointing to its node dot children ch minus a. Otherwise break, because no longer I can get the common prefix. Return what? Node dot index. Now the thing is clear. Now create a trie. Instantiate the trie equal to new trie. Once it is done, I'll do what? For int I equal to 0, I less than word container dot length I plus plus. Now insert into your trie dot insert. What I'm supposed to insert? This thing I'm inserting word container I at what index? I. But I make sure I have to reverse this thing. So how I'm going to reverse? Let's create string reverse using the string builder technique. We are going to reverse string builder. First create an object of this, then using the function reverse, then again translating it to string. So reverse. Now once my try is created, I'll just create an array answer, new int. It will be what? wordsQuery.length. wordsQuery.length. Now for int I equal to 0, I less than wordsQuery.length I plus plus, right? Now answer of I will be looking what? Try.query. Now word query of control Z, again it will be reversed. So string reverse will be what? New string builder of word query of I. Using the reverse function, I'll reverse it and then again changing it to string. Try query dot reverse. Once I get this index, I'll return what? Return answer. That's all. Let's see if there is any bug. We'll resolve that. Cannot find symbol try dot insert because it's insertion. So I'll do it insertion. Then any other array integer dot max value because it's e caps. Anything else? Two errors. That's all. Now it's getting submitted. I know it's hard problem, but when we'll start our try series, I'll like wrap up each of its basics. Let's submit this. It got submitted. Let's see its time complexity. What is its time complexity? First see the constant. Like we did a mistake, we have to see this constant in the very beginning. So wordsContainer dot length can go up till 10 is to the power 4. wordsQuery dot length can also goes to the length 10 is to the power 4. Now wordsContainer I dot length is less than or equal to 5 into 10 to the power 3. Same goes for words I dot length contains only lowercase character. It consists of only lowercase character. Sum of word container I is at most 10 to the power 5. Okay, same goes for this one. Now let's see its time complexity. Can anybody tell me what time complexity is going to be? Since let's see in the editorial. So it's and where n be the sum of the length of all string in one container, because that's how we are inserting, and be the sum of the length of the string in wordsQuery, so it will be n plus m, and space complexity will be big of n, right? That's it. That's all from my side. Thank you very much, and if you guys have any doubt, feel free to ask. I know today problem is a bit hard, but like that's how we grow. That's all from my side. Thank you. Bye bye.